of 8.1 is talking about power. So we learned about type 1 and type 2 error. The last component of that is talking about power. Power is when you correctly reject the hoe. So that's the way you remember. You correctly reject the hoe. You have all the power when you reject it correctly. When you correctly reject the power, when you correctly reject the hoe, you've got the power. Okay, power is equal to 1 minus beta.
Wait. Can we go back to this?
What is beta?
Something we learned from last class.
Last class. What kind of error is beta?
Type 2.
Type 2. So that means that power and type 2 are complements, meaning they add up to 1. Which makes sense because power is when you make what decision? Reject or fail to reject?
Reject.
You reject and you're correct. The opposite of that, a type 2 error, is when you do what? Fail to reject and you're incorrect. So it makes sense that they add up to 1 because those are opposites of each other. The first way to increase power is by increasing your significance level or increasing your alpha. If you want to make a little Greek alpha, you can. Why would that increase your power? What happens when you increase alpha? What happens to beta? Beta goes down. And if beta is going down from the equation that we just learned, if beta goes down, then power then also goes up. So
just power and A basically are the same.
Yeah.
Like they move the same.
Yeah, they're direct relationship. The second way is if you increase your sample size. So basically, the more people you sample, the more power you have because you have more evidence. And then the third thing is increasing the difference between the true population value and the null hypothesis value. Increase. I don't know why it says that. So, put increase. Well, you don't need this last increase, just the first one. That doesn't make sense. So what that means is, and I'm going to draw you a picture just to kind of clarify what that is, because you're probably just writing down these words and it doesn't make sense. Yes. So one of the examples on the homework, I think, was talking about a population value at 0.2. I don't remember what number it was, but maybe like number 2 or something.
No, it was number 1.
Number 1. And was it a greater than or less than test?
It was greater than.
Is it greater than a test? So when you take a sample, you're trying to have evidence against 0.2. So maybe in the first sample, like sample 1, you take a sample and you get 0.23. Then in sample 2, you take another sample. You get 0.30. Out of these two, so between 0.23 and 0.3, which one gives me more evidence against the 0.2? The one that is further away gives me more evidence because it is so far away from the 0.2, and we're trying to prove that it's greater. So if we're trying to prove that it's greater than 0.2, A sample that's close to 0.2 doesn't give me a lot of evidence, but a sample that's really far away from it gives me more evidence. So that's what it means between the difference between the true population and the null hypothesis value. You also might see it written like P sub 0 minus P sub A, which is a weird way to write it, but it's just saying like the null minus the alternative. It's just a different way to write it. Yes?
Is that what it means? Like when it's like more serious? Or?
Not that it's more serious, just that it gives you more evidence. So here we have an example, and this chart right here gives me some of the data that I need when things are changing, like what's happening to the power. So on the first column, this is when I'm increasing sample size. So my sample size is increasing. And these numbers right here are the numbers that I'm getting when I'm taking a sample. So that's increasing too. So the difference is increasing. And that's like your bullet point 3. That's what that's saying. So we're comparing these numbers to the 0.5. So like maybe the first sample we take is 0.52, then 0.6, and then 0.65. So what do you notice? Just reading all the stuff on the inside, that's all of my power. So what do you notice? What's happening to the power? When is it the best? Nearly 1 is definitely the most power, which means it has the what sample? The largest sample and the highest proportion. Or like the furthest away from 0.5. So you might want to write that because it won't always be highest. It could be the lowest. It just depends on what direction it is. So furthest away from 0.5, which is my null hypothesis. Yeah, in either direction. And I'll never ask you to calculate the power. It'll always be in a table like this. I could say, I could ask you, like, if you're given the power, maybe, if I said, what's the power at 50 and 0.52? I could ask you, like, what is beta from that? So how could I figure that out? 1 minus 0.09, which would be 0.91. So I can ask you the relationship between the two of them, but I wouldn't say just calculate it off the top of your head because that is a pretty lengthy formula, and we don't learn that. So here we have an example about guessing on a multiple choice test. You've got 4 choices, so guessing by chance is 25%. But a researcher believes that it's more than that the correct guess is actually 33%. So here it's the output of the power for sample size 50, 100, and 400. And it's a greater than test.
Always.
Okay. What is the power of the test if n equals 50? And it is that easy, you're just reading it. So power equals 0.3776.
Is there a symbol for power? We will always have
Just write power. Yeah.
Right, I would write P for power. Can we write P for power? Like, capitalize P?
Okay, next question. Write a sentence. What?
Can we make an honor stat t-shirt?
We can.
Buy it?
We'll talk about it in a minute. Let's finish these notes. Write a sentence providing the power of the test for n equals 100 and explain its meaning. What is the meaning for this?
The correct probably.
With a sample of 100, the definition of power is the probability of correctly rejecting. And what is the null hypothesis in context? Rejecting. Like, what is the null hypothesis? So HO is P equals 0.25. What is that saying in the problem?
A 25% chance of getting the right answer for multiple choice.
Yeah, so correctly rejecting the null hypothesis that or of correctly guessing multiple choice 25% of the time. That's why I'm giving it to you. So, probability of correctly rejecting the null hypothesis, which I'm just stating in context. That's what the null hypothesis is saying. Is, what is power? 0.5740.
So it's wrong.
So, the probability of rejecting the null hypothesis, of correctly rejecting the null hypothesis is 0.5740 if the proportion is 0.33.
So is that what
If it's saying
if I'm lucky,
So we have to write it just like this on the quiz.
yes,
I'm
something like this. And it's saying if the true proportion is 0.33. So add that in, true proportion. If the true proportion is 0.33.
of course.
So let's kind of break down what we need to add in here. I hope it's going to go away if I unfreeze it. Maybe not. No, okay, good. If the true proportion. Guys, stop talking. This is hard stuff. So don't talk. So you're going to say with whatever sample it gives you, and it isn't always 100, it could be something else. So whatever sample it gives you, the probability of correctly rejecting the null hypothesis will always stay the same. You'll just write that verbatim every time. Then you'll insert the context of the null hypothesis. So, with a sample of blank, the probability of correctly rejecting null of insert context is blank.
Will it always be true proportion?
If
Could it be
true proportion is blank. So these are the things you're inserting. Sample size. So whatever your n is. You're inserting context of the null, of the hoe. You're inserting power. And you're inserting the proportion given. So in this case, it's the 0.33. Like given against the null.
So it'll always be true proportion.
Mhm.
True mean.
If it is a mean, then it'll be mean.
Okay.
Like, it could be mean here. Okay, next question. If the researcher wants to have 95% power and is correct that the true probability of success is 0.33, would a sample size of 400 be sufficient? So basically, is my power over 95%?
Yes.
Yes.
Can we just say yes? So say yes, have a sample size.
Power is greater than 95%. You could say power equals 0.9705, something like that. Yes,
Can you go back to the?
it won't go back from the writing, because once I write again, it overrides it.
Oh, jeez.
If the true probability of success is actually 0.4, so now going from 0.33 to 0.4, what's happening? It's increasing. Would the power be higher or lower? Explain. Higher. How come?
Because it gets further away from the 0.25.
Yes. So the power would be higher because the difference between the null and true proportion increases. So the null is this 0.25. We call that the null. And whatever like other proportion that they give you is now considered the true one. Like that's the actual one from the sample that we took. So you're comparing the null and the true proportion. Okay.
Is the 0.34 the true proportion?
Yes. Or now the 0.4.
Okay.